boat travels 30 miles against the current in 5 hours. The return trip with the current takes 3 hours. Find the speed of the boat in still water and the speed of the current. So for these types of problems, I really like to use a table. So the first key is to realize distance equals rate times time. This is a formula you need to know, and it'll help us figure this problem out. So let's set up a table. Now we're going to have 2 trips, and for both of those, we're going to set up the distance, rate, and time in our table. Okay, so we know the total distance was 30 miles. It had a trip there and a return trip. So we know we're going to have 30 for both of the distance. Now one of the trips was 5 hours and one was 3 hours. So this was the 30 miles. The first trip was against the current. That means whatever the speed of the boat is, so I'm just going to put boat for the boat speed, we have to subtract the current because that current is slowing it down. Since this is a slower speed, it makes sense that it would take the longer time of 5 hours. Now the return trip was quicker, so you had the boat speed, but you added the current on. That current was kind of pushing the boat, making it faster, so it makes sense that this would be the slower time because they traveled it faster. So we can see our missing variables are in the rate location. So if we have distance equals rate times time, we can go ahead and solve for rate because those are the missing variables. So let's divide by t on each side, and we can see, oh, so we know also if distance equals rate times time, we also know that rate equals distance divided by time. And we're going to use that to set up each of these equations. We'll have 2 equations. So rate in this first one is b minus c. The distance was 30 and the time was 5. And the second one, the rate, so we'll use the same equation, rate equals distance divided by time. So rate was b plus c equals the distance still of 30 and then divide by 3. If we simplify these, we'll get b minus c equals 6. And then the second one, we'll get b minus c equals 10. Okay, now can you see what we have? We've got ourselves a system of equations. We have 2 missing variables. And so, oh, oops, I wrote that wrong. b plus c equals 10. We've got 2 missing variables and 2 equations, and so we need to solve for these missing variables. We can choose elimination or substitution. Now in this case, with elimination, when we want the same number but opposite, check these c's out. One's negative, one's positive. And so we're just going to do elimination. We add these 2 together. We'll get those c's cancel. We'll get 2b equals 6 plus 10, or 16. We divide by 2. So the boat speed then is going to be 8. And since it's miles and hours, we know the speed is going to be in miles per hour. Now we can use this equation, one of these, to find the current speed. So we also found out b plus c equals 10. So we put in 8 for b. So 8 plus the current speed equals 10. We minus 8 from each side. So we get c is just going to equal 2, or 2 miles per hour. Now you don't have to use, you can use x and y, you can use any variables you want. I just like using variables that help me remember what they stand for at the end of the problem. Also, it makes sense the current speed does have to be less than the boat speed. If the boat speed ends up being less, it wouldn't be able to go anywhere against the current, right? And so in this speed, since it was able to go against the current, we know the boat speed has to be greater than the current speed.